Hey, good morning, everyone. How you doing? I hope you guys are enjoying your weekend. Hope you had a great weekend. Hope you had a great Martin Luther King's Day. And I know I'm looking forward to you guys logging in and sending me any questions that you have. Please drop a question below if you need to in the Google Classroom input box here. That way I can be able to respond back to you and be able to answer any questions that you have. So what I want to do right now is this. I want to show you guys just a recap of what we did originally. So everyone should have their packet. If you don't have a packet, I'll make sure I upload it right now. I know I apologize. I meant to do that. But this packet has 4 lessons in it. If you was here this past week on Friday or Thursday, we went over 5.1, which is the very first page, which talks about graphing systems of equations. What I would like to do today is I would like to go into more work with graphing systems of equations. Now, if you already completed this, you have a feel for how to graph them, how to rewrite equations, and how to graph it on the coordinate plane, then you're in good position. You're in great hands. I would suggest that you go on Delta Math and continue to work on practicing there. That way you can complete your Delta Math assignment for today. What I know is if you are also complete and you feel like you got this, you understand this, what I will do today is I will upload 5.2, the video for 5.2 as well. That way you can see, well, how do I do systems with substitution? And I would love to teach you how to do that as well. So if you have your packet in front of you, I want you to look at 5.1 with me. And that's what we're going to focus on for today, okay? So I hope you guys take time when you're doing this video. If I go too fast, it's a great asset to say, okay, let me pause it. Let me rewind it. Let me take a second to really dissect what he was talking about, digest what he was talking about. And that way you could be able to say, oh, okay, I kind of understand what he's doing. You know what? I don't fully get it. Let me rewind it again. All right? I hope you guys enjoy the video. Let's start. How are you guys doing? Okay, so let's keep going. So what we're going to do today is this. You should have in front of you, you should have your packet, which contains lessons 5.1, 5.1a, 5.2, and 5.3. Now, as I told you last time we was in class, we're starting to work on a unit called Systems of Equations and Systems of Inequalities, right? In a system, that means that we have more than one equation, right? So a system is more than one equation. So in the case that I'm about to look at right now, as you can see behind me, we're given 2 equations. That means we're about to deal with something called a system of equations. What I want you to have in front of you is this. I need you to have your pencil or your pen, whatever you're writing with, have out your calculator, because I'm going to re-show you how do I check it on the calculator, how do I make sure that what I graphed or even what I found as my solution on my intersection is the right answer. I'll show you how to do that on the calculator. And in addition to your packet, you might want to have extra paper out as well, just in case that may help you regarding rewriting it, just in case there's not enough space on the actual worksheet itself. I tried to give you enough space, so I hope it all works out. But let's figure this out together, all right? So what you should be looking at, once again, is you should be on page 2, right? We're going to look at page 2, and I'm only going to do with you the modeling, which is the very first section here. After I do modeling with you, you should be able to complete the independent practice. Now, if you're like some of the students in my class, I was like, oh, I get this. This makes sense. I'm able to do it. And you already have gone on. You already have completed up to page 4. And now you're just waiting on me to teach you substitution. Once again, I'm going to try to post that video today as well, just in case you want to get a head start and want to complete that one as well. But I'm going to post 1 video a day. I think I'm going to post a substitution video later today, just in case you want to get a head start. All right? But I want you to internalize these methods. Don't just knock them out and be done with it just so you can get your packet done. Reminder, once again, the packet will be collected when you come back to school on Monday. So please take this time, get it done correctly. That way you can all get really good high grades on this as a quiz and a class assignment. All right, so let's look at what we have in front of us. So you should be looking at 5.1a, which is on page 2. And we all should be looking at the modeling. All right, so what I'm going to do here is this, right? They're asking me to find a solution to the system of linear equations. Reminder once again, we're talking about a system of equations which is more than one equation. If they're asking me to find a solution and their equations, every system of equations only has one solution. And as we talked about last time, right, that's wherever the value is true for both equations. So if we plug in that point into both of the equations, it should be true for both of them. right? If it's not true for both of them, then it's not the solution to both of them. Another way of finding that solution is by a method called graphing. If we graph it, what we should see when we go to graph the solution, it should form an X. If it doesn't form an X, then maybe they're not, maybe they don't have any solution, right? Maybe they don't have any solution to those, to that system, right? But in most cases, you're going to see it's going to form an X. And if it forms an X, wherever they cross is actually the solution, or another word is intersection. Okay, so what I'm going to do in this case is I'm going to go off and go to graph these two equations that we have on our paper. As you can see, we have 4x plus y equals 2, and we have x minus y equals 3. Now, both of these equations, they look good, but they're not in a form that I can graph them. The only form that we can graph an equation in is in the slope-intercept form. Well, what does that look like, Mr. Woodford? That looks like this, right? That looks like y equals mx plus b. Right, so we're looking to get it into this form. Y is equal to mx plus b. Once we get both of these equations into mx plus b form, then we'll be able to say, now I can go to my graph paper and I can graph it. But that's only when we get it into this form. If we don't get it into this form, we cannot go to graph it. So what I want to do is start off by this. I'm going to first start off with the first equation, rewrite it into slope-intercept form, and then we're going to work on the second equation to write it into slope-intercept form. When we get to the second equation, I want to make sure we pay attention to a little detail that maybe you missed in class, maybe it's still a little confusing for you, and that's whenever we have a negative in front of y, but we'll get to that in a little bit. What I want to do is this. I'm going to label, just so we all looking at the same exact one, the very first equation I'm going to write 1. And I'm going to use a red marker just so that way we can see it together. And for the second equation, when I go to solve it, I'm going to use blue, right? So if you can see these colors and they work for you, they make sense to you, awesome, right? But I want to make sure that we're able to look at them and see exactly my process as we go through. So let's start off with the very first one, which, as I said, I'm going to use the red marker, okay? Using the red marker, it starts off, I'm going to rewrite it, all right? It starts off by saying 4x plus y is equal to 2. So 4x plus y equals 2, all right? That's what I'm looking at. I'm going to draw me a nice little division, like a line going down here, just that way I can separate it. I want to use this side for the blue one, use this side for the red one. Hopefully it works out where it's not too messy, all right? So it starts off by having 4x plus y equals 2. My goal is to get y by itself. I got to get it into slope-intercept form, so I have to get y by itself. The only way I can get y by itself is if I move everything that's on the same side of y onto the other side. Now, because it's an equation, I have to keep it balanced. That means if I move something on the left side, I got to do something to the right side. That's the only way I can keep it balanced. It's a scale. So what I want to do is this. I want to get rid of this 4x that's next to the y. Now, the operation that's separating 4x and y is addition. The symbol that's in front of the 4x is a positive symbol. It's a positive 4, a positive 4x. So that means I have to do the opposite of positive and turn it negative, or subtract, in other words. So since it's a positive 4x, I need to subtract 4x. Now, once again, in order for me to keep it balanced, I need to do the same thing to the other side. So I'm going to subtract 4x over here. Now, I did cancel this out because 4x minus 4x gives me 0, so those cancels out. What I'm left with on the left side of the equal sign is just y. So y is equal to, right? And now I can write this. Now, I could write 2 minus 4x. Notice I cannot combine them because they're not like terms. One has an x, the other doesn't. So I know I cannot combine them. So I can either write 2 minus 4x, or I can write negative 4x plus 2, all right? I want to write it like this because I actually want it to be an mx plus b form. So now I can tell you, well, m is negative 4, right? What's this mean as my slope? This means I'm going to go down 4. I'm going to go down 4, and I'm going to go to the right 1, right? Every time that you see it and it's a whole number, right, that's in front of the x, that just tells you that I can write that whole number as a fraction. Put it over 1. Put that number over 1, and you'll have it as negative 4 over 1, which means go down 4 because it's negative to the right 1. All right, so this is my slope of this particular line. my y-intercept is going to be 2. Once again, y-intercept is my starting point, right? If you don't remember, what is a y-intercept? That means that's my starting point. When I go to graph it over here in the graphing on the coordinate plane, I'm going to start at B. I'm going to start on my y-intercept, and then I'm going to follow the slope. So this is where you start. This is where you end up following, all right? So this is good notes. Now, if you are taking notes or if you're taking a time, take your second if you need to. Pause the video, rewind the video, catch up with the notes, or take a second to really understand what we just mentioned, right? What we just did. How do we go from 4x plus y equals 2 to y is equal to negative 4x plus 2? So take a second to pause it or rewind it. Okay, so now let's go on to the second equation, right? We're going to go on to x minus y equals 3. We're going to go on to x minus y equals 3. I need to get it into y equals mx plus b form. So what I'm going to do is start off by the same way I started off the last one. I'm going to write my equation. I'm going to write it over here. X minus y is equal to 3. I need to get y by itself. So anything that's on the same side as y, I need to get over to the other side. I need to get it to the other side. So I'm going to say, okay, I know that there's an x next to the y. Let me get rid of the x. I'm going to get rid of the x. Now, the x is positive. I know there's a negative on the right side of it, but the x itself is a positive x. So if I want to get rid of a positive x, I need to use subtraction. I need to make it a negative x. So I'm going to make a negative x here, and I'm going to put a negative x over there. Or I'm going to subtract x, in other words, right? So I have x minus x. That, once again, it cancels out just like it did over here. I'm going to put a line through it. And then I have negative y on the left side of the equal sign is equal to, right? And I can write 3 minus x, but because I want to get it into mx plus b form, I'm going to put the negative x first and then that positive 3. So negative x plus 3. So this is what I end up getting. I end up getting negative y is equal to negative x plus 3. Now, did we solve for y? No, we didn't. Even though it looks like we may have solved for y, in all actuality, we solved for a negative y. We have a negative y here. We need to make sure we get y by itself. So the question then comes, okay, what number is in front of y? What number do we see that's in front of y right now? And I know we're like, well, I don't see a number. I see there's a negative or a subtraction sign. But we need to remember, we need to associate something called coefficients, right? We need to associate numbers that are actually in front of variables. So for a second, before we dive back into this, let me take a little detour right over here on this side of the board, right? If I were to say, okay, well, what number is in front of x here? You would say that's a 2. 2 is in front of x. That makes sense. There's no distinguishing that, right? But I also see that, okay, if you understand that that's a 2, then when I ask you what number is in front of x here, you would have to say how many x's are here. This is 2 x's, right? How many x's are here? There's only 1 x there. So since there's only 1 x there, the number that needs to go in front of it is just 1, okay? I can write this as x plus x, and that gives me 2x. I can just write this as just x. Even though the number 1 is not in front of it, I know there's only 1 x there. So that means the number that has to be in front of it is 1. This number is called a coefficient, right? This number is called a coefficient. You know, maybe later on as we go further in our units, you have to know, okay, this is a coefficient, that's a variable, and then this number up here is an exponent, right? So we'll be having to learn this vocabulary and apply it. But if I looked at something that was like this, back on what we have on the board here, right, we have a negative y. So let's go back over here to the board, right? We have a negative y here, right? This negative y, what does that mean for us? That means that we have a negative y, which is really not a negative y, but it's a negative 1. So if I were to rewrite this, I can write negative 1 y is equal to negative x plus 3, all right? In order for me to solve this, all I have to do is divide by a negative 1 on both sides. Divide by negative 1 on both sides. I end up canceling out the negative 1. I get y by itself. And I have to do negative x divided by a negative 1, right? And a negative divided by a negative becomes a positive. X divided by 1 is just x. So negative divided by negative now gives me a positive. X divided by 1 gives me just X. 3 divided by negative 1, right? A positive divided by negative gives me a negative. And we know 3 divided by 1 is 3. So my equation is y is equal to x minus 3. So my two equations that I end up getting, right, is x minus 3, and I get y is equal to negative 4x plus 2. So those are my two equations. Now here, yes, the slope we should identify is 1, which means 1 over 1, which means go up 1 to the right 1. And then my slope in this case is a negative 3. This is where I start at. So if I were to go and graph these two lines, right, let me graph the blue one first. I'm going to graph the blue one first. Remember, we have to label our line. We're going to start at the line step. We're going to graph up to m is equal to 1, okay? If this seems easy to you, you can fast forward it. I'll try to graph them as quick as I can. But make sure that we see that they cross. That's what we're looking for, right? So this is not our answer. Even though I circled the two equations, that's not what they're asking you for. They're asking you for the solution. So when it's all said and done, we should have our solution, right? We should write what the solution actually is. And that's what we should be circling, what the solution is. All right? So let's go to graph them. So I'm going to start off with the blue one. The blue one tells me start at negative 3. I make my dot at negative 3. The slope tells me go up 1 to the right 1. So up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. Now, if you couldn't go up any further, you can go down 1 to the left 1. Go backwards, right? Down 1 to the left 1. And I end up having a line that looks like this. All right, I hope you guys all have the same exact line on your papers, right? And you should be able to connect them and make it look very pretty, something like this. Remember, we're not done until we label it, so make sure you label it, right? Y is equal to x minus 3. Now, you could have wrote y is equal to x minus 3, or you could have wrote x minus y equals 3. Either equation, as long as you write it correctly, was either there or this one here. Just make sure this one is solved right. Okay? I go to graph the next one. The next one is negative 4x plus 2. I'm going to make sure I go to graph that. The y-intercept is 2, so I start at a positive 2. The slope tells me go down 4 to the right 1. So I'm going to go down 4 to the right 1. Right? Down 4 to the right 1. Now, it would be somewhere down here somewhere. Right? We can't fully see it, but I know it would be down there. All right? I draw my line. Right? I draw my line as neat as you can, as straight as you can. Right? Draw your line. All right? Let me try to go from down here. Something like this, all right? So this is what your line will look like, something like that. Remember, we also still need to label it. So we will label this as y is equal to negative 4x plus 2. Sorry, we're black. I meant to put it as red again, but it's okay, all right? My solution. The solution to this particular problem is wherever they cross. That's our solution, right? This is the technique called graphing systems of equations, which when you graph them, you will immediately see where the solution is, all right? And in this case here, you can see they cross at this point right here, 1, negative 2. Remember, the first point is x. We go over on x, then we go and see where the y is. The y is down 2. So the solution to this problem is 1, negative 2. All right, so that's your answer. That's what you want to aim for, okay? So if you got this and you're up to this point, this makes sense to you, awesome. Go on, complete the rest of 5.1a. That way you're able to do it. Now, if you want to always check your answer on the calculator, remember you have these two equations. You have y is equal to negative x, right? And you have y is equal to negative 4x plus 2. I would go to my calculator. Remembering these two equations, go to my calculator. Right? Go to your y equals. Hit y equals on the calculator. It's the top left button. Then you type in both of the equations. So start with y1, right? Type in maybe negative 4x plus 2. I would type in negative 4x plus 2. Awesome. Go down to the second equation, right? On the second equation, type in x minus 3. So now that you have both of your equations in, awesome. Go to graph them. See what it looks like when you graph them. Go graph them. And when you hit the graph button, you should see that they form two lines. Now, mine is similar to the colors I just used. Yours will probably just be black and white, and that's okay. It's okay. Your goal is to still find the intersection, all right? Now, if it's not in this standard form, right, follow the steps on the very first page. Make sure you put it back in standard form, okay? Put it back in standard form. The way you do that is you want to hit zoom, zoom 6. It says Z standard. Once you do that, it'll make sure it puts it in standard form for you, okay? Now, in order for you to find what the intersection is, right, and we just found it. We said that the intersection just now was 1, negative 3, right? Is that what we said? We said 1, negative 2, right? In order for me to find this section here, I would make sure, what I would hit is I would hit second, trace, right? So second, trace. Then I would go down to where it says 5. I would hit the number 5, okay? So click on number 5. Then I have to hit enter 3 times. So 1, 2, 3. And we should see that the intersection, X is at 1, Y is at negative 2, which means that, yes, we did do it correctly. All right? So go on, complete the rest of 5.1a. If you have any questions, feel free to drop them in the chat below. I will do my best to answer you. If this is not clear enough, I will try my best to reach out to you personally to give you a better explanation. But you can also go on Delta Math to be able to look at how they work through graphing as well. That way you're able to do an excellent job. I apologize for such a long video, but I hope that I answered any questions. I hope that all the information that was received was valuable. All right, please complete the worksheet. You guys are great. I'll see you guys in a little bit. All right, bye-bye.